We were talking about the steps which are required to be followed for assessments, and now something about the soil, its characteristics. And now we will start studying what actually soil characterization means and what is its significance. So first of all is the definition of soil. Everyone has direct link with soil: agronomists, civil engineers, so botanist, everyone is dealing with them in its own way. So please find these definitions quite self-explanatory. Now, soil particle. Soil normally constitute of gravel, sand, silt and clay. Furthermore, gravels and sand can be roughly classified as coarse texture, while silt and clay can be classified as fine texture. In addition to these, we have some rock fragments, some boulders, which are also constituting soil particles. So, what is the significance of these particles? So, in order to study this, we normally uh, grade a soil, what kind of particles, and in which proportion they do exist. So that's why we have a very uh, commonly used experiment which is called particle size distribution analysis, in which we conduct the in which we normally distinguish these particles with their proportions, and then we classify the soil on that basis. Now we have another term which is called gradation. Now this is very important. This gradation and then this sorting, very important topics. Please, I will request you to thoroughly understand this concept. Gradation is a measure of the distribution of particular soil sample. Larger gradation means wider particle size distribution. So it is kind of distribution in which we are normally having a segregation. We will be distributing all the uh, components in different segments. The best example of gradation is your markings. You are graded, you get A grade, you get B grade, C grade, D grade, E grade, F grade. So it is having a wide distribution of grading. So that means we have larger grading. So we have the more the gradings, that means wider the distribution. So if in a class we have every kind of student, in very minor with very minor distributions, that means it is going to have a very larger gradations. And similarly, when we call something well graded, it means it is having a very larger number of components which are involved in this part or this distribution. And then if it is not going to have a wider distribution, it is having a similar kind of trend. For example, all the students are having the same level. So all the students are very efficient and hardworking, and they are getting 80% marks every student. That means there is no different distribution. So very poorly graded. It is only have one grade. So that's kind of grading we can normally do. Grading and sorting are opposite to each other. Sorting is normally if normally a very normal term sorting which we use, that when we collect something of similar nature, for example, we are sorting out warm clothes, so we are collecting only one type of clothes, so we have only one category. So very well sorted means only one category. So these are opposite terms, sorting and grading. So now apply this concept on our soil. Let's consider our soil have only three components as explained here: sand, silt and clay. Let's assume these three are the basic components of our soil, and let's assume these are the only components in our soil. And if a soil is a well graded soil, it means it is going to have an equal proportion of these three components. Similarly, if we are going to say a soil is well sorted, it means the soil is going to have only one category of the components, whether it is only having sand, whether only silt, or whether only clay. So that will be called a well sorted. So just focus on well sorted and well graded, and the other end you can easily define. So well graded is poorly sorted. Well graded is poorly sorted. Poorly graded is well sorted. So please keep it in your mind while describing. Can you have an expression? If we have a soil with well graded soil structure, how it is going to have an impact on the movement of the contaminant or water through it? I think we will discuss it in detail in the next lecture. Now let's just go through these things. So homogeneous and heterogeneous is another category. So heterogeneous material properties vary widely from point to point within the soil mass. Homogeneous material properties are the same from the point to point within the soil mass. So what are the properties? So normally physical properties are considered in this, like density, like permeability. These are the things which are, if it is changing, then it is a heterogeneous soil mixture, and if it is not changing, then it will be declared as homogeneous. So then another differentiation, that is soil is uh, anisotropic if the property of being directionally dependent, as opposed to isotropy, which implies identical properties in all directions. Anisotropic means are not same in all directions. So isotropic materials are same in all directions. This is the common definition of isotropic materials. So if the soil properties are same, so for example, if vertical load is applied and the properties of the soil is not changing along the depth, that means it is isotropic. And if the behavior of soil is changing at different components at different depths, that means it is an anisotropic. Similarly, it is the soil behavior. If stress and strain behavior are same, then it means there is a linear relationship between these. So what are the benefits of linear and non-linear soil? Again, please go through it, and let's talk about it next time. Then we have the water table, and water table is actually the contour lines are similar to the topographic lines on a map. water table control lines. They essentially represent the elevations in the subsurface. So these elevations are called hydraulic head, mentioned above, and water table contour lines can be used to tell which way the groundwater will flow in a given region. So lots of wells are drilled and hydraulic head can be determined by finding out the water table level. So another important thing, the water table contour lines are also called equipotential lines, and the perpendicular to these equipotential lines will be indicating the groundwater flow direction. Please keep it in mind. It will be required in our next lectures. So water table is the surface where the water pressure head is equal to the atmospheric pressure, where gauge pressure is 0. However, saturated conditions may extend above the water table, and again we will discuss it in detail next time. So what are the sources of soil and groundwater contamination? I think it's very well known to you. Just go through these potential sources of groundwater contamination. Well, this is another important topic. What happens to the contaminants in soil? So this thing is something which need to be discussed in detail. So let's leave these topics for our next lecture. And so just for your information, site investigation is normally conducted by sampling and soil vapors and boring and groundwaters, and some remediation techniques may include pump and treat method. We can sometimes pump the water from the groundwater, bring it up, and then treat, and then again recharge into the groundwaters. Sometimes we can heat the contaminated area so that uh, the contamination may not spread, and we try to solve the issue by natural attenuation process. So these things we will discuss in detail in our coming lectures. So thank you very much for today's lecture. Next time, inshallah, we will continue with these last topics, and we will discuss these topics in detail. Thank you very much. Allah Hafiz.